The ship exhaust gas cleaning system is what we call the desulfurization system. For short, EGCS. So today, we're going to talk about these 5 parts, and the first part is the regulatory requirements of IMO. The second part is the principle of this system and PID drawings. The third is operation. The fourth is about component of our system. And the fifth is mainly talk about emission limit requirements and some related to the IMO. IMO divide the world's oceans to emission limit zone and non-emission limit zone. So for the emission limit zone, we call it the ECA zone. The sulfur content of the fuel must be less than 0.1. Then the sulfur content of the fuel for other areas must be less than 0.5. Well, to reduce the emission of this, the concentration of sulfur dioxide we used in this desulfurization scrubber. In the second part, we talk about the principle of this system. EGCS system is mainly divided into open-loop desulfurization system and closed-loop desulfurization system. Open-loop desulfurization systems are used directly seawater to clean the sulfur oxides that spread the exhaust gas. The chemistry is as shown above. For a closed loop, we use lye to wash the sulfur oxides in the waste liquid. Normally we use a solution of sodium hydroxide. For open-loop desulfurization system mainly consists of the following parts. First, seawater spray pumps. Followed by this main piece of equipment, scrubbers. The third is the flue gas analyzer. And the fourth is the water quality analyzer. The fifth part is the flue gas valve. And the sixth part is the sealing valve. As is shown in the picture, blue is the exhaust gas emitted by ships. The exhaust gas first passes directly through the smoke valve and then enters the tower. It is then washed with seawater. The seawater passes through the sea pump. And then the main part goes into the scrubber. Then wash smoke and then another way. Through the pre-spray pump into the auxiliary tower to cool the flue gas. The flue gas, after washing, is discharged directly into the atmosphere and detected before discharge. Check whether the value of the emitted smoke is up to standard. Seawater discharges are discharged directly overboard. A part of the water sample was taken out for testing. Check whether the discharge water is up to standard. This is the PID drawing of our project. First, the system takes seawater through a sea chest. It goes through our seawater spray pump. And then it goes through a flow meter. And then straight to our scrubber. To wash the flue gas, we have a water quality analyzer installed at the inlet. The analyzer samples and analyzes the imported water quality. We looked up the main road. One route goes through 2 pre-spray pumps. What this pre-spray pump does: water is sprayed to the secondary tower of the desulfurization tower. The purpose of this spray is to cool the exhaust gas entering the desulfurization tower. It can cool the exhaust gas from 200 to 300 degrees to normal temperature. The temperature of the seawater after washing is between 30 and 40 degrees. This portion of the water will go straight down and then be discharged directly through the sea chest. At the same time, we take a side stream of seawater before we drain it. Seawater is sampled and analyzed to see if the discharged seawater meets the standards. For flue gas, we collect it from the main engine or the generator. The flue gas passes through the secondary tower and enters the desulfurization tower. The smoke will pass through the filler first and then fully combine with the seawater. After cleaning the flue gas is discharged directly upward. At the same time before discharge, we use a flue gas analyzer for sampling analysis to monitor its emissions in real time and monitor whether the desulfurization effect meets the requirements. This is a simple plumbing diagram of a waterway. This part is the piping diagram of the ship's smoke. Our main cleaning flue gas mainly includes the exhaust gas emitted by the main engine and 3 generators. Take the main engine as an example. It will have 2 smoke valves. One is a direct discharge outboard as a bypass. The other way is into our desulfurization tower for washing. Let's look at the following section, which is some details of the main engine and the 3 generators. This includes some details like sensors. We can notice that there is also a sealing fan here. These 2 sealing machines gas seal the flue gas valves. In the case of flue gas washing, flue gas valve, the inlet flue gas valve will open and the bypass flue gas valve will close. In order to ensure that the flue gas valve is closed in good condition, ensure that no exhaust gas leaks out. We push pressure inside the flue gas valve through the sealing fan. By pressing the air to form a tight gas seal effect is good. Next we introduce the operating interface, which is the main interface of our system. It mainly includes the first part, are the various parameters of each combustion unit. As you can see, the load includes the main engine and 3 generators. And then the second one is the total load and power of the combustion unit. And this is a button. When we click this button, it goes into the pipe interface of our flue gas. And then this is our start-stop button. The 4th is our main interface. And the 5th is the alarm interface. The 6th is the data record button. The 7th is the event record button. And the 8th is the setting record button. The 9th is about our company's after-sales contact information. The 10th is switching between Chinese and English. The 11th is to perform local remote control switching. Because our projects generally set up local control screen and remote control screen. Use the switch button to switch the permissions of the local remote controller. The 12th is the details button. For some unimportant parameters, when the details button is pressed, those unimportant parameters are removed to simplify the page. The 13th is the button to switch the pump. 14th is the time button and time record. The 15th is the lock screen button. The 16th is the current status bar. 17th is GPS location. Then we can introduce the process through this main interface. The processing process of the entire desulfurization system, as explained in the PID diagram above. First, we get seawater from the sea. Then 2 spray pumps are used to spray seawater to the inside of the washing tower. At the same time, we can see that this spray pump outlet has a side stream. Go down to the pre-spray pump. The main purpose of the pre-spray pump is, it is to spray seawater to the secondary tower, and at the same time to cool the intake gas of the secondary tower. For the main spray and pre-spray lines, we have installed flow meters to monitor the flow rate. There is also a side stream at the exit of the pre-spray pump. It goes to the top of the desulfurization tower. The top of our desulfurization tower is equipped with a demister. When you start the system and when you stop the system, the valves on the upgoing lines of our pre-spray will open one by one. Clean the top mist dispenser. Then the sprayed seawater is discharged overboard directly through the discharge line. At the same time, as we can see, there's a water quality data at the bottom which includes imported and exported water quality analyzers. The data includes temperature, turbidity, pH, and Pa numbers. For smoke, the smoke from our main engines and generators. After passing through the secondary tower into the main tower. After cleaning, clean exhaust gas is discharged directly. At the same time, we use a flue gas analyzer. Real-time monitoring and sampling were carried out to obtain the flue gas values in the flue gas analysis. It includes the sulfur dioxide number, the carbon dioxide number, and the sulfur to carbon ratio. And as we can see, at the bottom of the desulfurization tower, install 2 level switches. The purpose of the level switch is mainly ensure smooth drainage of seawater. When the water doesn't drain smoothly, the water level will rise, triggering the level switch signal. The liquid level signal will cause the system to shut down, achieve the role of security protection. Good is an introduction to the operation of our system. First, our system can be used in both emission-restricted and non-emission-restricted areas. The difference between the two is that the emission values of the flue gas are not the same. The standards for emission restriction zones will be higher. When we start up, we can select the mode in our main control interface. Choose whether to use the emission restricted zone mode or the non-emission restricted zone mode, namely the ECA mode and the non-ECA mode. This is our home screen. Our system composition also includes the main engine, as well as some parameters of each generator. At the same time, these data will also be recorded in our interface. This is a simulation of our operating screen. Click the Detail button to display some detailed parameters. Then we enter the smoke interface. This is the main interface of our group. When it starts, you can choose between ICA and non-ICA. Now we select the ICA region, and then the smoke interface. So far, this is a simulation. And when it stops, click the Stop button and hold for 3 seconds. Then the system stops. And now it's into the non-ICA zone. These are the main devices included here, including our spray pump, pre-spray pump, water quality analyzer, flue gas analyzer, desulfurization tower, host, generator, and other signals. This is our smoke interface. The flue gas interface mainly includes seal fans, gas valves, and the power load of the main engine or generator. And then each generator or main engine has 2 smoke valves. One is for bypass. The other is for access to the desulfurization tower. At the same time, each gas valve corresponds to a sealing valve. The role of the sealing valve is, by obtaining the air from the sealing fan, the smoke valve is sealed. This is our manual mode. All devices can be operated manually. But you need someone with experience or someone who knows the logic of how our system works. Operate our system in manual mode. The password is 725. This is simulated manual mode. Click Menu and enter password 725. Once confirmed, we will enter the manual screen. Start the device you want to start in the manual screen, such as spray pumps and pre-spray pumps. Of course, before we start, you need to enter the frequency of the pump, and then these valves of seawater. It can also be opened and closed manually. This is going into the flue gas interface. To operate the flue gas valve switch, it should be noted that, when operating the flue gas valve switch, ensure that at least one of the switches is kept open. Make sure the main engine or generator not to be held in because of high pressure. This is our manual interface, including all kinds of pump or fan valve switch. Next up is our data setup interface. Parameter settings are included. After we finish delivery of the system, fix some parameters. It includes the range of some sensors and the numerical alarm of some sensors. Okay, let's move on. The password for entering the manual interface is 1. And then we'll see how to get in. First, click the Settings button. Then enter the password 1 After confirming, we enter the settings. The interface will include some parameters for all sensors, including some parameters of the main engine and generator. As we can see, including its upper and lower limits. That's the range of this sensor. And its low alarm value, high alarm value, low alarm value, and high alarm value. When we have changed the parameters, select the Save button. The parameters are written into the PLC. These parameters. We do not recommend modifying it as it is being used. Make a note of any changes. And after doing all the other tests, then change the parameters back to the original settings. This is an introduction to some of our manual interfaces. That includes setting the high alarm value, the low alarm value, and this range. And then for the data record, how do we copy the data? Well, the method is relatively simple. Just click the data interface on the side of the Export button. We can plug the USB flash drive into the USB port on the back of the screen. Then click the Export button. The data is then stored on a USB flash drive. It's important to note that when the save is complete, there will be a message in the upper left corner. When the message prompts, we successfully save the data and then unplug the USB flash drive. Now let's talk about the composition of the system. The main component is the desulfurization tower. Our desulfurization towers are mainly divided into two types, including U-shaped towers and I-shaped towers. The main difference between the two is that the U-shape has a secondary tower. The flue gas enters the secondary tower from above first, and then enters the desulfurization tower. The Type I tower is the flue gas directly from the bottom into the desulfurization tower for washing. The U-shaped tower would be relatively safe, with no risk of flooding the tower. But it takes up more space, and the Type I tower takes up less space. For a U-shaped tower, the internal structure mainly includes: first, the pre-spray part. The pre-spray part is the cooling effect of the flue gas. And then the bottom is the outlet for the discharge. The middle part is the filler. The filler is metal filler. The main function of the filler is ensure that the sprayed seawater is in close contact with the discharged exhaust gas. Ensure that the sulfur dioxide in the flue gas is fully absorbed. And then the top part is the nozzle for the main spray. The main spray nozzle is used for seawater spraying, and then the top part is the demister. The smoke from our washing is bound with water vapor. Therefore, we need to go through the fog eliminator to remove the water in the smoke. Then a drier flue gas is emitted. After a long time, the air will be dirty. So we use the demister to clean the lines. Clean the demister. This right here is the nozzle that cleans the demister. And then, this is the smoke valve. A smoke valve is also called a dumper. Its main function is control the inlet of flue gas into the main engine or generator, or bypass. Each dumper corresponds to an installed sealing valve. When the valve is closed. When our flue gas valve is closed, our sealing valve opens and enters the air for sealing. To gas seal this gas valve, to ensure this, the flue gas valve is completely closed, and there will be no leakage of exhaust gas. This is a physical picture of our smoke valve. And then for waterways, we have some pneumatic valves. This is our seawater spray pump. Seawater spray pumps include a main spray pump and a pre-spray pump. This is our sealing fan. In addition, some projects will have supercharger fans. This is our frequency converter. The frequency converter is used to control the frequency of the spray pump, thus controlling the main spray flow. For projects with pre-spray pumps, the pre-spray pump is also controlled by a corresponding frequency converter. This is a picture of our liquid level switch. After the level switch is triggered to ensure safety, to prevent the inundation towers, an emergency shutdown of the system is triggered. In addition to the level switch, we also installed a pressure switch at the inlet of the desulfurization tower. The function of the pressure switch is to ensure the smooth discharge of the smoke. The flue gas enters the desulfurization tower, and when the pressure is too high, it indicates that the pressure inside the desulfurization tower leads to the obstruction of smoke exhaust. The pressure switch triggers a hardware scram. The exhaust gas is bypassed directly when the system is shut down. The flue gas will no longer enter the desulfurization tower. In addition to the pressure switch, we have also installed the temperature switch. The temperature switch is installed at the top of the desulfurization tower. That's where the exhaust vents are. The main purpose of the temperature switch. It is to ensure that the temperature of the flue gas entering the scrubber and discharging the exhaust gas is to meet the requirements after washing. If the temperature of the discharge is too high, indicates that the exhaust gas has not been cooled or washed. At this time, the high-temperature exhaust gas will cause certain damage to the desulfurization tower. So install a temperature switch, make a hardware scram, to prevent smoke from entering the tower in the event of a system failure. In addition to that, there are some temperature sensors, pressure sensors. These sensors monitor the pressure in the waterway, including the temperature and pressure of the smoke. And then this is the water analyzer. There are currently two types of water analyzers we use. One is Chelsea and the other is CTG. For import and export water quality analyzers, we need to monitor the pH, temperature, and turbidity of the water. First of all, the water quality analyzer of Chelsea type is introduced. He mainly consists of two boxes. One is the box for sampling on the left. One does water quality analysis. The box is on the right. For this box we sampled. It consists of 7 main parts. The first is the junction box. The second is a bubble remover. And the third is a draining tank. The fourth is the drain pump. The fifth is the filter. The sixth is the sampling pump. The seventh is a variety of valves. When seawater is sampled, it goes through the sampling pump and then to the bubbler. The defroster removes excess air bubbles from the water. The discharged water sample enters the analysis tank on our right side through the pipeline. The data was obtained after analysis. Then the analysis tank drains the water sample. Access this water sampling cabinet, and then into the draining buffer tank. It is then drained through a drain pump. Discharge the remaining tested water back into the main stream. This is the analysis cabinet for the water quality analyzer. It mainly consists of 3 probes, which are pH sensor, pH sensor, and turbidimeter. In addition to these 3 sensors, there is also a flow meter inside to monitor the flow of the sample. Then there is the electrical junction box and screen for operation. The 3 sensors pH, turbidity, and pH are very important in use. These sensors also require routine maintenance. So for pH sensors, the crew is required to conduct a calibration once a month. It is replaced every year. Because the service life of the pH sensor is 1 year. The turbidimeter is more accurate every 2 years. For pH sensors, retrofitting is required every 2 years, because pH calibration involves some toxic chemicals. Calibration can only be performed in the manufacturer's return laboratory. Now let's introduce CTG's water analyzer. Its sampling and testing parts go together. This is the internal structure. The water analyzer takes the seawater from the inlet through the sampling pump into the deaerator after the defrosting of the seawater. First through the pH sensor, then through the pH and the turbidity and the flow meter. Then it flows back into the main channel. And that includes ours. The safety drain line is depressurized. And then there's some compressed air. Compressed air can be used to purge the sensor. This is the screen panel interface of CTG, which shows pH, turbidity, pH, temperature, flow rate. These are important parameters for CTG sensors. It also needs maintenance and maintenance. The pH sensor is also carried out once a month and is required to be replaced every year. The turbidimeter requirement is that it must be returned to the factory every year. PA sensors must be returned to the factory annually for calibration. For CTG's water analyzers, the turbidimeter and pH sensor cannot be calibrated at the crew and can only be returned to the factory for calibration. Next, we introduce the flue gas analyzer. There are two main types of flue gas analyzers. One is SIC and one is VMAX. Smoke analysis, also known as CMS, stands for Continuous Online Monitoring System. We measure our emissions of sulfur dioxide and carbon dioxide. First, we introduce the SIC type of flue gas analyzer. It mainly includes an analysis cabinet, a sampling probe. The sampling line also has a filter unit for compressed air. When in use, the sampling probe is installed on the top of the desulfurization tower. To sample the smoke, enter the analysis cabinet through the sampling pipe. Analyze the values inside the analysis cabinet. The purpose of the air filter is to connect compressed air to the gas analyzer for zero accuracy and purging, to ensure the air quality of compressed air. Therefore, it is required to install an air filter. This is the internal composition of our analysis cabinet. Mainly includes, the first is the monitoring unit. The monitoring unit mainly includes sampling pump and inlet filter. The sample gas is taken directly into the internal chamber of the measuring unit. The second is some optical components to carry out numerical analysis. The third part is some circuit boards. The fourth part is to sample some pipelines. The fifth part is some sensor signals, including temperature sensor, probe, temperature sensor above the sampling probe, etc. The sixth part is some solenoid valves. The sampling line is used to switch between the compressed air line and the more accurate sample gas line. The seventh part is the unit of pressure regulation. Adjust each air pressure. The eighth section is the drain line. The analyzed exhaust passes through this section and is then discharged directly into the atmosphere. For a flue gas analyzer, the SIC guy's smoke analyzer, his sampling probe needs maintenance. There are relevant requirements for the filter element on the sampling probe. The requirement is to check it every month and renew it every 3 months, to ensure that there is no dirty impurities into the flue gas analyzer. Another thing to note is that the source of the analysis. The requirement is to renew it every 3 years. Next is the VMAX type of flue gas analyzer. It mainly includes sampling probe, sampling pipeline, adjusting cabinet for sampling and analysis cabinet, and more accurate air. For VMAX's flue gas analyzer, the sampling probe also needs to be checked every month and replace the filter element at least every 3 months. At the same time, the VMAX flue gas analyzer requires the use of sample gas to be more accurate, at least once a month, for sample gas calibration. And the 6-smoke analyzer we talked about earlier. It can be calibrated directly internally and does not require sample gas for calibration. Next we talk about emission standards. The main emissions consist of 2 parts. One is the emission of smoke and the other is the emission of water. For flue gas emissions, the first is the ratio of sulfur dioxide to carbon dioxide. What we talked about earlier is the sulfur content of the fuel required for the emission restriction zone is less than 0.1%. That corresponds to a ratio of sulfur dioxide to carbon dioxide of 4.3. This means that in the ECA area, our flue gas emissions must be less than 4.3. The same goes for non-ECCA areas, which are areas of the high seas. Sulfur content less than 0.5%. That corresponds to the sulfur-carbon ratio. The emission requirement is less than 21.7. This is the only difference between ECCA and non-ECCA regions. In addition to the emission requirements for the sulfur-to-carbon ratio we mentioned earlier, there are also emission requirements for water quality. Discharge requirements for water include pH, pH, and turbidity. The pH emission requirement is less than 6.5 within 4 meters of the emission point. But we can't detect it at 4 meters from the discharge point. Therefore, flow field simulation is used for calculation.
Thank you.
Get the pH limit requirements for each project's discharge point location,
Thank you.
and through the Classification Society certification. Use this as the pH emission requirement for each project. For example, most projects will calculate a value of 2.8 or 2.9. So we could use 2.8 or 2.9 for this project. As the emission limit value of this project, it is also our alarm value. This is a variable number for pH, as required by law. It is the flow of seawater sprayed by the current running time, and the total power of the main generator to calculate. So, the limit value of pH during operation is a variable. For turbidity, the turbidity value of the discharged seawater and the inlet, the average value of the difference in turbidity values of seawater within 15 minutes. If the value is less than 25, the requirement is met. The above is the introduction of Qingdao Shuangrui desulfurization system that I introduced to you. Thank you.